Moving forward with our series of ladder logic videos, specifically for electropneumatics, we're going to take a look at how we can make a cylinder go out and retract, but only if it's retracted. In that, if someone presses start and it's not retracted, it won't actually go. Okay, so we're going to look at that with a single solenoid spring return DCV and a double solenoid DCV and see how the two ladders are a little bit different there. And more specifically, what we're doing is we're using our inside limit switch, because the logic is that if it is inside and someone presses play, it works. But if it's not inside and someone presses start, the signal doesn't go through. It doesn't happen. Now, it's not going to want to extend if it's not extended anyway, but we want to add the logic in, maybe for safety, to say, no one can press start unless it's actually retracted. Let's take a look at what that looks like over here. Maybe we'll start with over here, because I think it's simpler over here. All right, so we know that when I press start, it's going to go out and it's going to come back, but I want to add a little bit more logic to that. So I'm going to do this. That's my 24 volts. I'm coming in here. I know that I'm actually going to extend this a little bit more. I'm starting real basic. Like, the thing that's great about having whiteboards and whiteboard pens and pencils and paper is that you can erase stuff, because you'll end up erasing stuff for sure when you're doing ladder logic. Okay, so I'm going to put my solenoid in here. That's my 0 volts, and I'm coming down here. So now I know that that is going to be my solenoid A plus. When I press play, it's going to extend, and I think we've done that already. You know what, let me put my retraction in here as well. So I'm actually going to put this guy here, and that is my limit switch A plus. We know that my limit switch A plus is normally open, held open, solenoid A minus. So in this case, when it gets out, this will become closed, and now it will send it back. And as long as I have my finger off the button over here, it will come back. If I were to hold my finger there, it would actually extend and stay extended, because this guy, even though that energized, because that's still energized, and it moved the spool first, unless we kick the voltage up on this or something, it's not going to be able to overpower this. They have the same amount of strength. Okay, so our logic has to be added in here, a new logic that says, if someone presses this button and it's not home, then it won't go out. More specifically, if it is home and someone presses the button, then it will go out. So what I'm going to do is I'm going to put a contact in here. I'm going to put this guy, and we know that's a normally open, but it's held closed. So down here, this is my limit switch A minus. So we know it's a normally open limit switch because it says so over here. That's the symbol for it. And all of the limit switches in the lab, in the Humber lab, that you guys will be dealing with are actually normally open. So if you want to reverse the logic at any point, you have to stick it onto a relay. Okay, let's continue. Okay, so here, this guy is held closed. I'm going to write that down. This is normally open, held, closed. Okay, so it is closed. When this thing gets home, this actually closes it. So, okay, in its normal state, it's actually open, but it's in a held state right now, so it's closed. Okay, we're good with that. So now, if I press play here, yes, it will extend. As soon as it starts to extend, this becomes open, and that de-energizes. Okay, that's okay, because we've already moved this. This, all it does is move the spool in here, and there's no spring pushing it back, so as soon as the spool's moved over there, it stays into a 1-4 state. Okay. It's different over here. Let's take a look. I'm going to draw this 24 volts. I'm going to come down here. I'm going to do the same thing over here, and I'm going to say we're using the inside limit switch. This is a normally open, held, closed. I'll label it again. Normally open, held, closed. And this is my LSB minus. Okay? Now, again, I've got my push button here where I'm going to press my push button, and I got my solenoid. Okay, so this is my 0 volts down. Now, this is my solenoid, sorry, B plus. Okay, good. So, now, this is the problem. When I press this button, this is going to start to move. But you know what? I do have power here, so yeah, it will start to move because this guy is held closed. So there's power right here. There's voltage potential right there. As soon as I press that, that energizes. This becomes active. It moves the spool. This starts to move. It goes about that far. And as soon as it goes that far, this becomes open, and it just comes back. So what's going to happen here is if you hold your finger on that button, that cylinder is going to go bang, 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 bang. It won't go more than that, because as soon as it leaves this limit switch, well, it becomes open. So we need to put a holding circuit on this. All right, I'm going to put like a standard traditional holding circuit. That's maybe what you're thinking. So I'm going to do this, right? And then I put a relay there, and I call it my R1-1. But the problem is, it's actually gonna be worse, because if I press the button and release it, it's still gonna go bang, 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 because this is gonna stay held. Actually, no, that won't even stay held, because this will become open. No, it's not gonna work. What we have to do is extend that holding circuit, and it's okay. We can do that. This is kind of maybe a new concept for you guys. You can hold two things in a holding circuit. Fine. You can actually hold a bunch of stuff. I could put a whole bunch of logic in here. I could put something in parallel. I could put like another. I'm just doing this. Over here, if I really wanted to, I could put another limit switch in here from, say, another cylinder somewhere in parallel with that. And I could even put maybe another limit switch in here, and then whatever. I could put tons of stuff in there. And I could hold the whole piece of logic. So I could describe some really complicated piece of logic there. If this switch and not that switch, and or this with the or of all of that, whatever that means, I can make it really complicated and then just hold that whole thing. So I'm going to get rid of that little kind of holding circuit over here, because we want to stay nice and simple. So my point here is it's okay to hold two things in a holding circuit. All right, so all the holding circuit, okay, absolutely. I've drawn a holding circuit, so I got to do my R1, and that's going to be my R1-1. Absolutely, I need that relay there. Let's take a look. Oh, I see a problem. My problem here is that an open termination contact, but I think you see it coming. Okay, now, if it's home, that will be closed. When I press this button, I have power. That energizes, this also energizes, this becomes closed when I take my finger off of this, and when that opens. As this is moving, I'm going to take my finger off that button. The button will become open. But as soon as it passes here, this will become open, but that's okay, we got it held, so it will continue to go out. Now, I want it to come back when it gets out. Let me just kind of throw that in here. Oh, that's already in here, so I'm going to throw that in here. Let me just put it in here to see what happens. Now, I need to use this guy. He's a normally open limit switch, and there's nothing holding it, so it's normally open, held open. So I can't actually use it here because it'll be open and nothing will ever start. So that's why I need to put it on this rung over here, and I need to put a relay on that, R2, and this guy is going to be my limit switch A, to B plus, and over here, I have to put a contact from that relay that is a normally closed, so R2-1. Now, whenever you're looking at your ladder logic, just stop. Just pause and just say, okay, if nothing's happening, what's going on? Not only do you have to look at your ladder logic to kind of analyze it, as though, what happens when I press the button? Or what happens when this happens? No, just don't do anything. Look at it in its held state first. That's that quiet state where nothing's going on. Analyze your ladder logic in its held state first. So let's do that. In this ladder logic, in this held state, if I don't do anything, that guy's open, that's de-energized, that's closed. It's in its normal state, so it's closed. It's a normally closed contact. Okay, good. So this guy is in its held state. It is closed. It's a held closed contact. So it's closed. When I press play here, the current will go through there, but because I'm not pressing play, there's no current going to that. That's not energized. That is open, so there's no current going through there, and nothing's happening. Good. Now, when I press the start button, I do have power here. Yep, that energizes, this energizes, that becomes closed. When I release it, that becomes open, that becomes open. When it gets out, this becomes closed. Yep, it works. Good. So that's how you go through your ladder logic. So what we've just learned is, we've learned how to deal with an inside limit switch. More specifically, a normally open inside limit switch that's held closed. And we actually found over here that we had to hold this whole thing. And that's because this DCV is a solenoid spring return DCV. It has a normal position, just like a normally open switch. If I activate it and I want it to stay that way, I've got to put a holding circuit on it. This is a normal position DCV. It has a normal position. If I want it to stay in an active position, I have to put a holding circuit on it. There you go. So you have to put a holding circuit on whatever is activating it into that. And in this case, the thing that's activating it are these. Yeah. In this case, the thing that's activating this is this and this. Did you get that and? Yeah. It's because they're in series together. So when we put two things in series together, we call that an and. If I wanted to, I could actually put another thing around here that, let's say I put another push button over here, normally a push button, then these two are ORed and they are ANDed with this, but I'll get rid of that. We'll throw something kind of more complicated into another ladder logic a little bit further about more like ANDs and ORs and kind of describing things in that manner. That's it. Let's move on to another circuit where we're actually going to just keep this concept in here, but add some more parameters.